Hello viewers. Today I am going to talk about the concept of goodness of fit and use of R squared and adjusted R squared as a measure of goodness of fit of a statistical or econometric model. Very often we need to determine how well the model fits with the data. There are a number of ways to do that. There are a number of goodness of fit statistics that can be used to test how well the model fits with the data. For example, a key information criteria for AIC, R squared statistics, adjusted R squared statistics. These are some of the important statistics which are often used to test the robustness of the model. Among different important statistics, R squared and adjusted R squared are intuitive measures of how well a model fits a set of observations. So today's very short video is focused on R squared and adjusted R squared value. So let us start with estimating a model. So I am using the same model, same data set from the previous video. So our dependent variable is PC, food expenditure, then constant. So we are doing least square here, so we should write the ls in the program line. So we have a number of independent variables. So we are estimating that model here. Here is the result. So where can I find the R squared and adjusted R squared? Here it is. In this case, the R squared value is 0.69 for 1 and the adjusted R squared is 0.6904. What does it mean? What does R squared mean? It means that 69% variation in the dependent variable can be explained by the independent variables jointly. I am repeating the statement again. Here the R squared value means 69% variation in the dependent variable, in our case per capita food consumption expenditure, can be explained by the independent variables, all the independent variables significantly. In other words, we can say that 69% of the fluctuations in dependent variable can be explained by the independent variable jointly. That's the explanation of R squared and adjusted R squared. So we see that R squared is a measure of how close the data are to the fitted regression line. It is also known as the coefficient of the determinations. The definition of R square is pretty straightforward. That is the percentage of the response variables variation that is explained by a model. It explains the amount of variation explained by the least square linear model. So the R squared value is always between 0 to 100%. In general, I'm using and I am giving emphasis on the word in general, the higher the R squared value, the better the model fits with the data. Again, it's important, it's a general statement. There are some explanation and lot of issues are associated with that. I will also touch some of the issues. So, as I have just mentioned that the higher the R squared value, the better the model fits with the data. So here we can see the R squared value is 0.69. It's pretty good. So the model fits with the data very well. Then the obvious question comes, what should we report in the results? The R squared value or the adjusted R squared value? It's a very important question to us. So R squared value is in fact used if we have only two variables, one dependent variable and one independent variable, or in case of bivariate model, we report the R squared. On the other hand, for multiple regression, we report the adjusted R square. That is important for if we have good number of independent variables, then usually we use the adjusted R squared statistics uh, to uh, to explain whether the model fits with the data. It's a very important statistics to show the robustness of the model or how the model fits with the data. But however, there are some limitations of that statistics. Number one is R squared cannot determine whether the coefficient estimates and predictions are biased, and R squared does not indicate whether a model is adequate. That is, it is possible that you can have a very low R squared value for a good model, or a higher R squared value for a model that does not fit the data. Then another obvious question comes, are low R squared value inherently bad? So the answer is no. If your R squared value is low, but if you have a statistically significant predictions, you can draw important conclusion about how changes in predicted values are associated with changes in the response variable. So this is important. So the higher R square value doesn't mean that your model is a good fit, so we have to be careful on that. That's all about R squared value. Thank you very much for watching.